Drinking bird, also known by other names such as insatiable birdie, dunking bird, dipping bird, and dippy bird, is a bird-like toy without need for electricity or fuel that resembles a bird drinking from a water source. Its continuous operation can begin when the beak of bird gets wet. In its continuous operation, drinking bird toy, while oscillating, remains at its standing or upright position. But from time to time, it rotates to move the beak and head of bird downwards in order to touch water and make the beak wet, after which it rotates back to its standing position. As long as the beak remains wet, drinking bird toy continues this resemblance of water drinking. The continuous operation of drinking bird toy, amazingly and strangely, doesn't require any electricity or fuel. And it has been reported that when its working mechanism was kept camouflaged, it had amazed and baffled even some great scientists and engineers, including Albert Einstein. Let's see how this amazing, strange toy works. Drinking bird toy has two hollow bodies, or simply two hollow bulbs, one as the head of bird and a bigger one as the body of bird. These two hollow bodies or bulbs or head and body of bird are connected to each other through an elongated hollow cylinder, or simply a tube, which can be considered as the neck of bird. The tube extends from the boundary of the head at the point of juncture with the head to an appropriate distance into the interior of the second bulb or body of bird. In other words, the tube extends pretty much all the way into the bottom bulb, but just attaches to the top bulb without extending into it. Two bulbs and their connecting tube are well sealed, or in other words, they form a closed system that doesn't permit transfer of matter into or out of the system, though transfer of energy is possible. Two bulbs and their connecting tube are initially substantially evacuated of air, and instead they have a suitable amount of a liquid such as dichloromethane with the formula CH2Cl2 that readily vaporizes and condenses with reasonable vapor pressures at ordinary room temperatures. There is also a beak attached to the head, which is coated with a wick-like or felt-like material to absorb liquid water, where wicking material can extend all over the head, especially when the beak is internally separate from the head. In addition, the whole of these pivot on or rotate around a point on the neck of bird, which is chosen or adjusted in the way that when liquid rises in the tube, bird becomes top heavy and topples, or rotates to move head and beak downwards. When the beak gets wet due to evaporative cooling in ambient air, the head of bird becomes cool. In other words, from outside wet surface of the beak, liquid water evaporates to the surrounding air, and for this it absorbs heat required for evaporation from the beak and head of bird, making the upper parts of bird cool. While due to evaporative cooling, upper part of bird is maintained at slightly lower temperatures than the room temperature, the lower part of bird with no evaporative cooling but a relatively large area exposed to ambient air will approximately remain at the room temperature. Therefore, when the beak is wet, there is a slight temperature difference between upper part of bird as its cool portion and lower part of bird as its warm portion. Drinking bird toy exploits this slight temperature difference to operate. The liquid inside bird can readily evaporate to produce its vapor, while on the other hand, its vapor can readily condense to produce back the liquid. This combined evaporation and condensation tries to reach and maintain an equilibrium, at which the value of vapor pressure depends on temperature, with higher vapor pressures at higher temperatures and lower vapor pressures at lower temperatures. Therefore, inside bird, at cool upper portion of bird, due to more condensation, vapor pressure is lower, while at warm lower portion of bird, due to more evaporation, vapor pressure is higher. This pressure difference pushes the liquid of the bottom bulb into the tube and raises the liquid level in the tube. The rise of liquid in the tube displaces center of mass and makes bird top heavy. So bird topples and rotates around pivot to move head and beak downwards. As a result, the beak of bird touches water and absorbs liquid water to remain wet and provide liquid water for evaporative cooling. While the beak of bird touches water, the tube inside bird remains at angles above the horizontal, down towards the bottom bulb, with the end of tube at the bottom bulb coming out of the liquid surface. With the end of tube out of the liquid surface, the liquid in the tube gravitationally falls back to the bottom bulb, and gaseous parts of top and bottom bulbs get the opportunity to become connected and mixed together, which makes the top bulb slightly warmer and the bottom bulb slightly cooler, and also eliminates the pressure difference between them. With liquid back to the bottom bulb and momentarily no pressure difference to rise the liquid into the tube, bird again becomes bottom heavy and while oscillating rotates back to its standing position. Again, evaporative cooling can make the head cool, while heat from surrounding can maintain the bottom bulb warm. Therefore, operation of toy resembling water drinking can continue. Drinking bird toy to operate requires careful construction and arrangement. One main feature is the choice of liquid. The temperature difference between upper and lower parts of bird due to evaporative cooling in ambient air will be slight in the order of a few tenths of a degree Celsius. With this slight temperature difference, a large enough difference between vapor pressures of upper and lower parts in the order of several tenths of a kilopascal is required to push and rise the liquid of the bottom bulb into the tube in the order of a few centimeters to displace center of gravity and make bird top heavy. For this to be possible, the chosen liquid should have high vapor pressures at ordinary room temperatures, which means it should have low boiling points close to the room temperature. In this regard, another related property is the heat or energy required to evaporate the liquid. As the chosen liquid should readily evaporate and condense, lower heat of evaporation is better, where this is also connected to and correlated with lower boiling point. Based on these, liquids such as dichloromethane, chloroform, carbon tetrachloride, and ethanol are among good choices, while liquids such as water are among bad choices by which drinking bird toy might not even function. Besides the choice of liquid, other considerations and arrangements should also be taken into account, such as amount of liquid, size of parts, amount of air evacuation, thickness of parts to tolerate pressure difference between inside of bird and ambient air, etc. It is also good to consider that at different conditions, drinking bird toy will function differently. In this regard, one main factor is conditions of evaporative cooling. For example, by increase of humidity of ambient air, evaporation of liquid water from the wet surface of beak of bird will become slower to finally stop at saturated humidities. As a result, drinking bird toy will operate slower and less vibrant by increase of humidity of ambient air and will not operate at saturated or near saturated humidities. As another example, due to faster evaporation of ethyl alcohol than water in ambient air, if instead of water ethyl alcohol is used, drinking bird toy will operate faster and more vibrant. Here it is important to consider that while drinking bird toy without need for electricity or fuel can operate as long as the beak is kept wet, this doesn't mean drinking bird toy is an example of a perpetual motion device. A perpetual motion machine is capable of doing work infinitely without an external energy source. A perpetual motion machine is hypothetical as it would violate the first or second law of thermodynamics, or both. Drinking bird toy is not a perpetual motion device, as drinking bird toy uses ambient heat to evaporate liquid water reversibly. Drinking bird toy is an example of a heat engine, where a heat engine is capable of converting heat to mechanical energy and work, such as a desired motion. Drinking bird toy has also its own amazing history. In the United States, it was patented by Miles V. Sullivan in 1946. Before that, it was described in the popular Russian science book Physics for Entertainment, first published in 1913, written by Yakov Isidorovich Perelman, a Russian and Soviet science writer. Before that, there were mentions of devices and heat engines such as Mintoville in 1881 and pulse hammer by 1760s, which operated in ways more or less similar to drinking bird toy. Anyway, here we can see that how drinking bird toy without need for electricity or fuel operates, beside many other amazing facts about it. This is interesting, isn't it?